Faraday's laws of EMI. Faraday's laws of EMI, from the different experiment which he has performed, on the basis of that he has concluded certain points. So we can write, on the basis of different experiment he has concluded certain points. First is, whenever there is a change in magnetic flux, persists. Whenever there is change in magnetic flux persists, the EMF induced in the conductor, whenever there is a change in magnetic flux persists, the EMF induced in the conductor, and if conductor is making a loop, then in the loop current establishes. That current is called induced current. That current is called induced current. This is the first point of Faraday's law. So what Faraday has suggested, that whenever there is a change in magnetic flux persists, the flux present is not important. The change in flux is important. Whenever there is a change in magnetic flux, then only EMF induced in the loop or in a conductor. And if that conductor is making a closed loop, then the current will establish, and that current is called induced current. Now, second point, the magnitude of induced EMF is equal to the rate of change of magnetic flux. Equal to the rate of change of magnetic flux. It means induced EMF E written as d phi by dt. Here we are using modulus. Later on we will discuss about the polarity and direction. So the magnitude of induced EMF is equal to the rate of change of magnetic flux. This is the second point he has given. Third point, if conductor is making a loop of resistance, R, then current is established in the loop. Then induced current in the loop is given as see, induced current I is equal to E by R. E is the induced EMF, so 1 by R d phi by dt. This is the meaning of induced current. So this is very important relation for induced EMF, and this is also very important relation. Induced current is equal to I is equal to E by R. E is the induced EMF by resistance R, and 1 by R d phi by dt. So see the fourth point of Faraday's laws. As current is flowing through the loop, as current is flowing through the loop, so there is a flow of charge, so amount of charge flow through the loop is given as, so amount of charge flown through the loop is given as, see, from this relation, as I is d phi by R dt, so dq written as I dt, which is your d phi by R. So delta q is your delta phi by R. By this we can determine the amount of charge flown through the loop. Delta q is equal to delta phi. Delta phi is nothing, change in flux by resistance R. Now come to the next law, that is called your Lenz's law.